Hi everybody, I wanted to quickly talk through some of the nuances of the scatter plots that you guys made. Remember, this is exploratory for now, but you are starting to experiment with some of the encoding options, including storytelling, like labeling the extremes, or in this case, adding in us, because everybody likes to know where we fit into things. So some of these plots I thought just made really interesting stories to explore. Like this is the relationship between obesity rates and alcohol consumption, with GDP as a secondary indicator in size, and then colored by continent to get a sense of the regionality. Yeah, and I think it just kind of leads to an interesting story. You've got a lot of large GDPs, but then we've got this regional thing happening out here. It's just kind of an interesting clustering. Gave me food for thought. No pun intended. Okay, so this plot is the relationship of life expectancy to murder rates, and it's showing us the somewhat intuitive relationship where low murder rates correspond to longer lives. But remember, relationships are not causative, right? Correlation is not causation. And I think that's really important to remember. It doesn't mean that one of these is driving the other. It's just a relationship. Okay, the coloring by continent, I think, just is more evocative. We get this actually like flatlining in Europe with a couple little rule breakers, but Africa really stands out as being distributed all over the place. And then again, labeling some of the extremes, I think, just draws our attention to the story. On this one, it's the relationship between urban population growth and fertility rates. Life expectancy is encoded in the size of the mark. But notice how difficult it is to see that. If you look at the legend, there isn't a big difference between the low value and the high value. And this is really important. Tableau is limited to proportional symbols. Do you know why? It's because the size of the mark has to remain proportional to the value it's representing. If a value is twice as big as another one, its mark's area can't be more than twice as big as the other one. So ARC gives you the option to use graduated symbols or proportional symbols. Graduated symbols are the one that allow the user to set the size of the min and max valued point. But as you've hopefully picked up from the lectures, exaggerating the size of a mark is a form of lying in data viz. So it's tempting to want to do that, but honest visualizations require an adherence to the proportionality of the values and their encoded marks. So that's why Tableau limits you. It just doesn't let you make mistakes like that, like ARC does. And on maps, maybe there's a reason to say, okay, we need to have graduated symbols, but maybe there's just another way to do it. Here's another example where the proportional symbols are showing the raw population counts. And so here we have a much bigger range in values in population. And so you get a more exaggerated difference in the symbol areas. So you don't ever want to really, change your plot just, to get the look you're going for. But you do have to consider these things. In the last plot, if the point wasn't about life expectancy, then there's no reason to put it on one of the axes, because the axes are kind of the drivers of the story. This is supplemental information, because position along an axis or position along a scale is an easier thing for humans to decode than area or color. So your primary messages should be on your axes, and the supplemental stuff, or the things that you don't need people to extract like specific numbers from, those can be encoded with area and color. Okay, so I do, even though we are just doing exploratory data visualization in these first exercises, I always applaud the effort to change away from the default colors. It's just so nice to see a different color scheme, isn't it? Okay, in this example, I just want to start talking about when it's a good idea to visualize, and it doesn't have to be for a formal plot that you do, for an infographic or sharing with your audience, because you need your audience to be comfortable reading log scales. But when you see a really cramped and unevenly distributed data set like this that's really skewed, this is a great time for you to go in, edit the axis, right click, edit axis, click on log scale, and it spreads this sucker out, just so that you can get a better sense of the distribution and see if there is a pattern with the continents or the geography or the GDP or whatever else it is that you're encoding in color or size. So this is the same thing. It's GDP versus military expenditures. I just have a different symbology on it. And this is what it looks like after you convert it to log scale. It's not a huge change. The other thing I did is I got rid of the subcontinent coloring and just put it to regular continent. And you might not see a huge change. And in fact, we have quite a bit of stacking down in the lower ends here. And so what I would do next is just right click, edit the axis, and change GDP to log scale as well, and see this thing spread out. Okay, so this is another example of a really skewed distribution, and it would be interesting to see it displayed in log scale as well, just to spread out this cluster and inspect for regional patterns. I also want you to notice that continent is being encoded with both color and shape, and this is called dual encoding. Some data visualizers, like Edward Tufte, think that that's like chart junk or wasted ink, and I tend to disagree. But I would caution you to use dual encoding carefully, because what it does is it strengthens the message of this one variable that you're dual encoding. So sometimes I think it's really effective. I have COVID on the brain. It's really effective to use dual encoding, because it just tells a stronger message. But like I said, you need to be careful not to dual encode things that aren't the star of the show. But this was just an example of that. So here GDP has a pretty good numeric spread for size. So it works well for size, and the more subtle variables can be on the axes here. Okay, and then finally, this is showing food consumption related to obesity rates. And then alcohol consumption is encoded with size, and geographic region is done in color. So there's a ton going on here, and it is really interesting. But I want to draw your attention finally to the coloring here. So the way these sub-regional labels are set up, Asia or Europe is after the modifier northern, and it's alphabetical, and then it's categorically colored, or not quite categorical, but it's like orange, green, light green. There's not a lot of organization here, but Asia is definitely not together. We've got Western Asia down here, Southern Asia here, so we've got green, pink, orange, two oranges. So what happens here is we get disaggregation and kind of categorical colors spread to these sub-regions. So we're getting more data depth, but we're losing the bigger aggregation. What would be better here, and maybe the way to fix this, would be to manually go in and give all of the Asia qualifiers, shades of yellow, and then give all of the Europe subregions shades of green or something like that. Or you could go into Excel, create a new column, and then just rearrange the way these are labeled so that when it's alphabetized, Asia is all together, Europe's all together, the Americas are all together, Africa's all together. And that would help you organize the colors a little bit better. So you could still have differentiation between the subregions, but overall, you'd maintain the character of the continents. So just something to think about. And then just really briefly, here I have life expectancy against obesity rates with energy use per person, encoding in size, and then color for continent. And I just want to show you that even though you're stuck with the proportionality of these symbols, it doesn't mean you can't change the symbol size, but you have to shift everything up. So you can still adjust the size and kind of plump everything up. And you can also play around with what type of shape, and a lot of you have been doing this, but maybe combining size with shape, lets you get a view of the data that you wouldn't normally see. I think you need to be careful too that, like right here, there's just this weird little cluster up here, and if you look, there aren't any values for energy use, and that's why they're so small. So the no values or the nulls could be skewing this too. I don't think they do, but it's possible. The other thing I wanted to show you really quick is notice in the pop-up here, I've got continent, life expectancy, obesity, energy use, but I don't know what country it is. And that's really easy to do. You just drag the country to the tooltip. And now when I click or hover, it's added country. Now I can see that this one's South Africa, this is Kuwait, Singapore, Japan, and South Korea. So I don't know, it's just a really easy trick to learn. So that's it. If you have any questions, let me know. Color this week, and I'll see you guys next week.